tonight your flipped videos on factoring. Okay? Factoring, today in class we talked about addition, subtraction, and multiplication. We didn't really say anything about division though, right? Now, division is really a pre-cal topic, division of polynomials. You do something called long division, you do something called synthetic division. However, in Algebra 2, we do need to break some polynomials into their separate parts, which sounds like division, and it kind of is, but we call it factoring. Okay? So the first thing that we're going to do when we factor is we're going to look specifically for a greatest common factor. Is there anything in all of the terms, or in this case both terms, that both terms are divisible by? Well, hopefully you can see that that greatest common factor would be 2. When we factor out of 2 of each term, we're dividing each term by 2. If I divide this term by 2, I have an x squared. If I divide this term by 2, I have a 4. And that's it. That's all I can do on that particular problem. Okay? So what if you have a problem like this? 3x squared y plus 9x. Well, hopefully you can see that each term is divisible by a 3, but hopefully you can also see that each term is divisible by an x. Each term has an x in it. Okay? Once I divide this term by 3x, divide this term by 3 and I get a 1. If I divide this term by x, I get xy. Because remember, when I divide by x, I subtract my exponents. If I divide this term by 3x, I get a 3, because x divided by x is just 1. Okay? So again, when I'm factoring, the first thing I look for is if I can factor out a greatest common factor. The greatest common factor here is 3x. Next, on a problem like this, x to the 4th plus 5x to the 3rd y plus 7x squared y to the 4th, I'm looking for a greatest common factor. Well, the first number doesn't even have a coefficient at all, so I'm not going to be able to take a coefficient out or divide each term by a common number. But hopefully you see that each of the terms have an x, and the biggest number I can take, the biggest x I can take out of each number is an x squared. Happens to be the lowest of the exponents, if that'll help at all. Okay? But if I factor out an x squared from each term, I'm dividing each term by x squared. So what I have left is x squared. What I have left is 5xy. And what I have left is 7y to the 4th. And that's factoring out a greatest common factor. Okay? We're going to be factoring several types of polynomials, including binomials, trinomials, and polynomials with 4 terms. Okay? The most common type that we will factor are the trinomials. Okay? I'm going to focus on this part for the rest of the flip video on the factoring trinomials because of the fact that it's the most common. Okay? But I'm only going to focus on the very first part, the very first step. It's not going to make complete sense on the flip video. Hopefully it will help us tomorrow though. Okay? So I want you to think of two numbers that multiply to be 20 and add to be 9. Well, what two numbers multiply to be 20? 1 and 20, 2 and 10, 4 and 5. Will any of these combinations give me a sum of 9? Well, hopefully that you can see that 4 and 5 will multiply to be 20 and add to be 9. Okay? Think of another one. What two numbers will multiply to be 3 and add to be 1? I think I wrote that backwards. Yeah, sorry. Oh, I just didn't put this in. I needed actually to add to be 4. Okay? What two numbers will multiply to be 3 and add to be 4? Well, what two numbers multiply to be 3? Only 1 and 3. Will 1 and 3 multiply to be 3 and add to be 4? Yes. So it's the numbers 1 and 3. Okay? Again, we're only talking about the very first part, but this is pretty essential part, so I'm trying to get you to think about it beforehand. Okay? What two numbers multiply to be negative 6 and add to be a positive 1? Well, 1 and 6 and 2 and 3 multiply to be negative 6, knowing that one of these numbers has to be a negative for it to be a negative 6. So which combination will give me a positive 1? Well, hopefully you see that it'll be a negative 2 and a positive 3. Now, am I guessing on these numbers? Well, I'm not really guessing, but I'm making a very wise choice. I'm writing down some things I know will multiply to be 6, and I'm just using my brain to figure out which ones will add to be 1. Okay? Last one. What two numbers will multiply to be 8 and add to be negative 6? Well, 1 and 8 and 2 and 4 multiply to be 8, right? So what do we have to do to add to be 6? Well, this is what I also want you to think. Negative 1 and negative 8 multiply to be 8. Negative 2 and negative 4 also multiply to be 8. So hopefully you see that negative 2 and negative 4 will add to be negative 6. Okay? That's the kind of thinking we're going to need tomorrow when we factor our trinomials. We have some other things to go through for our binomials and our polynomials with 4 terms, but we will start there. Please fill out your WISC and have a great evening.